Pluto is a distant and stealthy, more unpretentious planet that was once a piece of our nearby planetary system. However, advancing, disturbing announcements by leading astrophysicists Neil deGrasse Tyson and Mayo Kaku have brought Pluto back into the spotlight. They proposed that this chilly world is on a potential collision course with Neptune. But how could this really work, and what might be the results of such an enormous event? Are we seeing a bewildering, huge erraticism, or is there something else to this looming, unending setback? Join us as we take a gander at the potential results of a Pluto-Neptune impact. Pluto, a past planet that was reclassified as a dwarf planet, remains a subject of interest and study in the vast universe, as shown by recent guesses from leading specialists. Pluto's orbit is perilously close to Neptune's, and astrophysicists Neil deGrasse Tyson and Mayo Kaku are both raising the alarm about a potential hazardous accident between these two planets, which could represent a massive risk to Earth. But how is such an event even possible? Pluto's trip around the Sun is unlike that of any other planet in our solar system. It requires a dazzling 248 years to complete a single orbit, and since its discovery in 1930, it hasn't even finished one full revolution. At any rate, the interest doesn't stop there. Pluto's orbit is marked by its particularly elliptical shape, wandering widely from the almost circular orbits of the major planets. What makes Pluto's orbit much more surprising is its inclination, which is 17 degrees to the ecliptic plane. The way Pluto follows its path is significantly more irregular compared to other planets. This tendency and unpredictability add layers of complexity to its orbital arrangement. Potentially, one of the most intriguing parts of Pluto's orbit is its intersection with Neptune's. For about 20 years in each orbit, Pluto actually moves closer to the Sun than Neptune, defying what we might expect from their positions in the planetary system. This prompts the usual question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational effects of other planets. The examination of Pluto's orbit began shortly after its discovery. Initially, astronomers attempted to figure out its unique path. Unlike other planets whose orbits lie fairly close to the ecliptic plane, Pluto's orbit stands out with its deep inclination and erratic shape. The mystery grew with the realization that Pluto's orbit does indeed cross Neptune's. The stability of Pluto's orbit, despite these intricacies, is evidence of the complexities of celestial mechanics. The three-body problem in space involves determining how three objects in space, like Pluto, Neptune, and the Sun, move and influence each other with their gravity. It's like trying to predict where they will go based on where they started and how they pull on one another. In Pluto's case, this problem shows how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complex way. The terms non-concurrent libration, orbital precession, and VZK wobbling are key to this puzzle, as explained by astrophysicists. What keeps all planets in their orbits is non-concurrent libration. In regard to Pluto and Neptune, this term essentially means that when Pluto crosses Neptune's orbit, it is positioned no less than 90 degrees away from Neptune. This spatial division is critical in preventing their orbits from meeting. Orbital precession, on the other hand, refers to the vertical movement of a body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned far above their orbital plane, adding an extra layer of protection from potential impacts. Another key factor in this situation is the VZK wobbling, named after three researchers, Zell, Kai, and others who studied how objects move in space. It involves how three space objects, like Pluto, Neptune, and the Sun, pull on each other with their gravity. This pulling influences how they move. In Pluto's case, the VZK wobbling helps us understand why its orbit close to the Sun is so unusual. Despite Pluto's orbit appearing chaotic, this wobbling helps keep it moving smoothly over extended periods. The VZK wobbling shows that although things in space seem wild and unpredictable, patterns and rules maintain some control. These forces help keep Pluto's orbit stable, ensuring that it doesn't collide with Neptune or drift off course. This three-body problem is crucial in understanding how these orbits change due to the way space objects pull on each other. Studying this helps us learn more about Pluto, our solar system, and even distant worlds and their stars. Numerical simulations in the late 1980s revealed that, despite the stabilizing properties, Pluto's orbit is actually erratic, with minor deviations in initial conditions leading to huge differences over centuries. However, these peculiarities of Pluto's orbit have been found to maintain stability over extremely long timescales. Checking the disruption from later automatic examinations has helped us understand how the giant planets, like Neptune, Jupiter, and Saturn, affect Pluto's orbit around the Sun. Neptune has a special relationship with Pluto, where for every 2 orbits Pluto completes around the Sun, Neptune completes 3. This relationship helps keep Pluto's orbit stable. However, Neptune isn't the only one at work. Jupiter's gravity also plays a colossal role in stabilizing Pluto's orbit. Saturn also contributes. These studies show that Jupiter's massive gravity is strong enough to ensure Pluto stays on a steady path for a long time, potentially even for millions of years. So maybe Neptune, Jupiter, and Saturn are cooperating to make sure Pluto continues to move safely through space without running into trouble. These idiosyncrasies are key to keeping everything in place and safe in space. Without these mechanisms, the solar system as we know it would be a much more violent place. Bodies like Pluto could collide with others or be ejected from their stable orbits, triggering a chain reaction with other celestial bodies. For Pluto, especially with discussions about it potentially colliding with Neptune in the future, understanding its orbit is crucial. This gives a clearer picture of the dynamic nature of the nearby planetary system. The case of Pluto shows how even the most seemingly unstable orbits can reach a state of balance through the complex interaction of gravitational forces and orbital mechanics. It also underscores the importance of constant observation and study of these phenomena to better understand our place in the universe. Exploring the depths of space often leads us to confront the strange nature of celestial bodies, and Pluto's orbit is an ideal example of this irregularity. The concept of orbital chaos, which refers to the fragile dependence of a celestial body's orbit on its initial conditions, is clearly demonstrated in Pluto's case. This means that even slight changes in the dwarf planet's position or speed can dramatically alter its long-term orbit. Using automated simulations has been hugely helpful for scientists in figuring out how Pluto moves in space. These simulations use complex mathematics to model how Pluto and other space objects, like Neptune, pull on each other. By tweaking small details in the simulations, space researchers can see how even minuscule changes can make a huge difference in where Pluto ends up. In the late 1980s, these simulations showed something interesting about Pluto's orbit. Despite having features like asynchronous libration and orbital precession to keep it stable, its orbit can still be inconsistent and unusual. If you start with just a small difference in where Pluto is or how fast it's moving, its orbit could end up looking completely different after just a few years. Yet, despite this chaos, Pluto's orbit remains stable over vast timescales, like billions of years. This means that Pluto's journey around the Sun has a kind of order to it, even though it appears wild at first. Predicting celestial movements, especially when they involve irregular orbits like Pluto's, is a massive challenge. The inherent unpredictability of these systems means that long-term forecast tests are often filled with uncertainties. While numerical models provide excellent tools for understanding and predicting the future movements of celestial bodies, they also highlight the limits of our predictive abilities. These models heavily depend on the accuracy of initial conditions, and any small mistake or distortion can lead to vastly different outcomes, making precise predictions a daunting task. Other than the chaotic nature of planetary orbits, Pluto reminds us of the ever-changing and dynamic nature of the universe. While we've made huge strides in understanding space, Pluto's case reminds us of how much our knowledge of the universe still remains limited. Grasping the gravitational effects of the giant planets on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It shows how the presence and position of each planet can significantly affect the stability and course of other bodies within the system. So, why are leading astrophysicists recently raising concerns about a potential collision between Pluto and Neptune, despite all these complex forces trying to prevent such an event from happening? Neil deGrasse Tyson, a prominent astrophysicist and a major figure in advancing cosmology, offers a unique perspective on the mysteries of our solar system, especially the intriguing case of Pluto. Tyson, known for his role in renaming Pluto from a planet to a dwarf planet, offers insightful analysis on the evolving nature of celestial mechanics and the public's interest in the neglected corners of space. Tyson's position on Pluto's renaming is based on the ever-expanding knowledge of our solar system. He sees the renaming not as a diminishment but as a necessary adjustment to our growing understanding of the various bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of continuous learning and change. He sees the complexities of orbits like Pluto's as a sign of how much there is still to discover in space. The interest in these questions keeps the study of space so exciting. However, despite Tyson's optimism, his thoughts on Pluto's potential collision with Neptune paint a different picture. His concerns about the future of the dwarf planet come with a scientific eye. As Pluto's orbit continues to change, Tyson sees a possibility of a collision with Neptune. What would this mean for the system as a whole? Would Neptune survive? Would Pluto be destroyed? These are questions that leave us wondering how future research could offer more answers. Despite these concerns, there is still no clear evidence suggesting that Pluto's orbit will eventually lead to a collision with Neptune. While Tyson's warnings highlight the dangers of underestimating the complexities of planetary orbits, they also point to how much more we need to learn about the dynamics of space. As we look to the future, it is crucial that we continue to study the intricate relationships between planetary orbits in our solar system. From the smallest dwarf planets to the largest gas giants, our understanding of these cosmic mechanics will undoubtedly expand, offering us deeper insights into the potential fate of bodies like Pluto. In conclusion, the future of Pluto's orbit is uncertain, but its stability, despite the potential for chaos, offers a glimpse into the complexity and beauty of the universe. We may one day have answers to questions about a possible Pluto-Neptune collision. However, for now, we can appreciate the intricate, remarkable journey that Pluto continues to take around the Sun. The idea of a Pluto-Neptune collision, though fascinating and perhaps unsettling, raises questions about the ultimate fate of celestial bodies in the context of a vast and unpredictable universe. The real takeaway here is not just about the potential for planetary destruction, but the forces that shape the orbits and trajectories of all bodies in the solar system. In some ways, this scenario, though improbable, offers a dramatic illustration of how our understanding of the cosmos must continually evolve. While the chances of an actual impact remain slim, the idea of such an event forces us to think about the long-term dynamics of our solar system in ways that are not always immediately apparent. In fact, the very idea of planetary instability or potential destruction underscores a larger, more profound truth about the universe. Its nature is governed by laws that are both predictable and chaotic in equal measure. The ongoing study of Pluto's orbit is a case in point. With its irregularities and oddities, Pluto is a reminder that even in the seemingly ordered universe of our solar system, the unexpected can happen. And beyond that, Pluto serves as a symbol of how far we've come in our understanding of the cosmos. When it was first discovered, Pluto was seen as just another planet in the far reaches of space. Over the decades, however, our understanding of what constitutes a planet has evolved. The debate over Pluto's planetary status continued to spark heated discussion in both scientific and popular circles. But one thing is certain: the dwarf planet has captured our imagination, keeping us focused on the mysteries of the universe. As our knowledge of space continues to grow, so too does our appreciation for the complex dance of gravitational forces that bind planets, moons, and asteroids in their orbits. Whether or not Pluto will ever collide with Neptune, or whether its orbit will remain stable for billions of years to come, remains an open question. But in the grand scheme of things, Pluto's journey through space reflects the larger story of discovery, exploration, and the search for understanding that has driven humanity to look ever farther into the stars. As we look forward to new technological advancements in space exploration and astrophysics, it is likely that more answers will be uncovered about Pluto, Neptune, and the nature of their orbital dynamics. New discoveries are made almost daily in the field of astronomy, from the exploration of distant exoplanets to the study of ancient celestial bodies. These findings will help us piece together the puzzle of the solar system's past and future, and potentially offer us more insight into whether a dramatic collision between Pluto and Neptune is a reality we need to prepare for or just another fascinating cosmic possibility. In the meantime, we can marvel at the breathtaking complexities of space, and the ongoing efforts of scientists to untangle its mysteries. What we do know is that our understanding of the universe is far from complete. As researchers continue to study the interactions between celestial bodies, we can rest assured that there is much more to learn. The journey through space is far from over, and every new discovery adds a new layer to the ever-expanding story of the cosmos.